Good afternoon, everyone, and welcome. My name is Michael O'Donovan. I'm the chair of the Electrical Division of Engineers Ireland. I'm joined here today by another committee member, Ed Arnett, who will be doing the question and answer section. We're delighted to host this webinar today. We're supported by the Energy, Environment and Climate Action Division, and their representative today is Dolan Kassan. I would like to thank Kate Markey from Engineers Ireland Sector Support for her help in organising this event. So let's look at today's event. Today's session is the energy transition, wishful thinking needs to be replaced by realities of engineering, finance and project delivery. What it's going to look at is the practical challenges Ireland faces in moving to secure, affordable and reliable low carbon energy systems. As I say, if anybody has any questions, they can put it into the Q&A section that you'll see at the bottom of the page. So let's introduce our speaker. We're very pleased to have Eamon O'Reilly. He's the Director of Belfast Harbour Commissioners with us. Eamon is a chartered engineer with distinguished career spanning engineering, consultancy and major port developments, including his 12 years as Chief Executive of Dublin Port. So please join me in welcoming Eamon O'Reilly. So it's over to you, Eamon. Thanks.
Great, thank you, Michael. So Kate, if you wouldn't mind just putting up the first slide, please. So the title of the presentation today, it's the energy transition. What's the 2050 action plan and timeline? And we had a byline on this: wishful thinking needs to be replaced by the realities of engineering, finance and project delivery. So this talk today, it focuses on a report that we published earlier this year. And if you just put up the next slide, please, Kate. And the report, it's available on the Irish Academy of Engineering website, and it's one of a series of reports we have been putting out. So we put out a commentary on the Ireland's hydrogen economy around the time the hydrogen strategy came out. In June 2024, we put a report out about small modular reactors. This report about the energy transition came out earlier this year. And actually just on Monday next, we have a follow-on report being published called Rebalancing Ireland's Energy Policy. So if I don't put you off with this talk today, you might be interested in that. So if we go on to the next one, please, Kate. So I think thinking about energy systems in general, I always find this Sankey diagram from the Lawrence Livermore National Laboratory very interesting. So it takes us on the journey from primary energy through final energy consumption to energy services. And I always think what's remarkable is the amount of energy that gets wasted until we actually get the services that we want. And it's about 2/3, 1/3. So about 2/3 of the energy is wasted. It's wasted because of thermodynamics. It's wasted because of the inefficiency of internal combustion engines and all those sorts of reasons. But things are changing, and there is an electrotech revolution. It's a phrase that Ember have started using, and we'll see it on the next slide, which I think, as I bring myself back, if you wouldn't mind flipping on, please, Kate. If bring myself back to the origins of my education, the early parts of my career, you can't help but get excited, I think, by what renewables offer. The notion that we can have electricity generation with no losses, I think it's just an extraordinary thing. And even back in 1981 in UCD, Professor Harry Power was lecturing us about this potential long in advance of the renewables industry taking off like it has. So we have a great possibility to greatly reduce our primary energy, bring primary energy close to final energy consumption. And then on the consumption side, just through the efficiencies of electrification in transport and in heating, internal combustion engines very inefficient, electric vehicles very inefficient. You take away an awful lot of the wasted energy that Sankey diagram showed. And likewise in heating, where a very efficient condensing boiler with about 90% efficiency can be replaced by a heat pump with, not quite the right word, but 350% efficiency. So I think when we look at the environmental sustainability part of the energy trilemma, there's huge things there to be excited about, things that can be achieved. But in the trilemma, there also are issues of energy security and issues of affordability to be thought about. And there are then beyond that, the challenges of building all of the infrastructure needed. So the talk today really focused on the security, the affordability, and the project delivery. And that is a theme that we're trying to get much more focus on in energy policy in Ireland. And if you go on to the next one, please, Kate. I always find it amazing in conversations that I very seldom hear people talk about what's it going to be like in 2050 in terms of the supply side of the electricity system. And to me, and maybe it's because of my background in the port, 25 years is actually quite a short time when you're planning infrastructure. And it's doubly so when you're planning an awful lot of infrastructure. So we have been using two figures in our reports, in the SMO report and in the report I'm talking about today, and indeed in the one that's been published on Monday, where we look at a possible electricity requirement of 80 terawatt hours in 2050 and a maximum demand of 12,000 megawatts. And those two figures really are just the averages of what EirGrid had in the four scenarios they had in their excellent Test 2023 report. And when you put the figure for demand, maximum demand, down on a graph and look at it, you see this extraordinary exponential increase. And I think of exponential increases, 2.6% from 76 to 24, and then 2.9% up to 2050 possibly. All the alarm bells start going off. Janie Mac, that means a huge amount of investment, a huge amount of physical infrastructure to be built. And I just don't get a sense that as a country, we have got our head around the sheer scale of what it is we're attempting to do with going towards 2050 to try to attain carbon neutrality. And if you go to the next one, please, Kate, I think it's worthwhile just looking a little bit at where we've come from over the last almost 25 years, 1990 to 2023. The changes have been extraordinary in the electricity. So previously I talked about energy, just looking specifically at electricity now, where the total electricity requirement has more than doubled from about 14 terawatt hours up to about 35. From zero renewables, we now have 40% of our electricity coming from renewables. And notwithstanding that huge increase from non-renewables, we actually have more in 23 than we did back then. But the dirty stuff, the coal, the peat, and the oil are disappearing, and our coal and peat are virtually gone. But we are left with a very considerable amount of our electricity coming from natural gas, full 44% in 23. So we now have a system where, let's say, 50% from non-renewables, 40% from renewables, and 10% from imports. And if you go on to the next one, please, Kate. Within the report, we tried to develop a narrative and separate out issues. What technologies are proven, what technologies are not proven. And under the not proven, we put in floating offshore wind, we put in hydrogen, and we put in SMRs. And what we mean by not proven, I suppose, is if you were to do an auction tomorrow for floating offshore wind, I doubt if you'd get anybody who would put a project forward. Likewise, hydrogen and nuclear is obviously illegal in Ireland. So we have a set of proven technologies. We know that onshore wind works. We don't have much. Sorry, we have an awful lot of it. We don't have much less than Denmark has in terms of onshore. We have very little fixed bottom offshore, but Britain just across the water has something like 16,000 megawatts. We don't have much solar, but we can look to countries which similar to Ireland, like the Netherlands, which have a lot of solar. We know that storage works. We know that strategic storage of natural gas works, and we know that interconnection works. So when we think about all of those proven technologies, and then we look at what's in policy, the amount of renewable power in policy it's extraordinary. There's 37,000 megawatts of offshore, 9 of onshore, and 8 of solar, 54,000 megawatts, which going back to the 12,000 figure I postulate for 2050, that's 4.5 times the power capacity of the likely maximum demand in 2050. And you kind of look at that figure and say, gosh, is that possible? And you then have an electricity capacity, generation capacity, energy capacity, approaching 180 terawatt hours for a possible demand of 80 terawatt hours. And these figures would again cause you to sort of ask questions. So in the report and in the appendices, we run through the proven technologies, and we kind of argue that the onshore 9, that should be doable, the solar of 8 should be doable, and fixed bottom offshore wind at about 20,000 megawatts, that should be doable, but there are significant challenges. So you end up with a lower, what we think, feasible renewables capacity compared to what is in government policy, which we just don't think is feasible. And pulling these numbers together then, on the next slide, we have a diagram within the report where we have a look at what the electricity system might look like. There's an awful lot of assumptions behind the numbers here. Some of them I've just outlined. But I think the amazing thing is, with only 25 years to go, that we're having to make assumptions, big assumptions, to take a view on what the electricity system might look like. The biggest change is that if we look at the green box, that's my 80 terawatt hours and my 12,000 megawatts of max demand. In the past, we had a system, conventional generation only. So one single set of assets was delivering the electricity requirement for the country. We're now moving to a system where we're going to have 4 sets of assets. We're going to have that same conventional generation, but it's now going to be backup generation. We're obviously going to have renewables. And to make renewables work, we need to have a lot of storage on the system, and we need to have system services, batteries and synchronous compensation to do the stuff that conventional generation does inherently, which you don't even need to think about, or let alone have to pay for. And we also have a lot of interconnection. The 7813 figure there, that's an average figure from what EirGrid have in their scenarios, and that looks an awful lot. So beyond that, then, we have to fuel the backup conventional generation plant, and we only see a possibility at the moment for that coming from methane, either natural gas or biomethane. We have the security of supply issue, so we definitely support the development of an LNG import facility, probably bigger than is currently proposed. We included in the diagram then in orange to facilitate the discussion in the report, the possibility of renewables driving electrolyzers, producing hydrogen. And we put a figure of about 13.2 terawatt hours of that's lower heating value of fuel storage, be it methane or whatever else, for 30 days. And I'll come to where we get to those figures in a little while. So if you flip on to the next one, Kate, one of the things that gets talked about an awful lot about renewables is the obvious challenge of intermittency. But in the report, we say really policy does not adequately deal with the consequences of intermittency. So we've included an analysis from 2024 over the course of the year. And at the end of last year, we had something like 4,730 megawatts of wind. And when we do a histogram on how much was available over for different periods of time, there was from 0 to 500 megawatts, from about 5,000 megawatts for 2,127 hours in the year. Huge amount of the year, very, very little wind. There's nothing startling, but I think we all know this. And if you look at the top end, from 3,500 megawatts up to 4,000 megawatts, only 77 hours in the year were we getting power output at that sort of level. And we juxtapose then on that histogram the maximum demand, 5691, the blue out to the right, the average demand, 3,500 to 400 megawatt in that band, shown in the green, and then the I guess it's orange, the minimum demand. So even with almost 5,000 megawatts of wind, We very seldom last year were able to generate from wind enough power to meet minimum demand. One of the solutions that is obviously overbuilding wind, but the extent to which you can overbuild is you're going to hit large constraints in terms of price, in terms of just the physical delivery of projects. So there's a big unknown within Irish energy policy at the moment as to how much renewables we should actually be building. We definitely say 54,000 megawatts doesn't make any sense. We think that the 30,000 we've said is feasible is probably more than we would need or be able to accommodate for a whole variety of reasons, not just technical ones, but economic ones as well. But it is an elephant in the room type issue that just hasn't been adequately addressed. And we will be dealing with that in a bit more detail in the report that we're publishing on Monday. If we jump to the next one, Kate, when I looked at the trends from 1990 to 2023, the 10% of electricity in 2023 was coming from interconnectors. And I think there have been extraordinary things happening on imports of electricity into Ireland in the last couple of years. So we did an analysis, apologies for all of the numbers, but if you just look at the bottom line, and in 2024, about 15% of electricity was imported. That is about 5.1 terawatt hours. 2.4 of that came from Scotland to Northern Ireland over the Moyle interconnector, and then across the border into Ireland. And added to that, it was on the East-West interconnector, 2.7 terawatt hours, 5.1 terawatt hours, 15% of our electricity in 2024. And that was before the Greenlink interconnector was energized, and it is before the 750 megawatt interconnector to France comes on. So I think we have a pattern developed of Ireland becoming a major importer of electricity. And in that regard, we're pretty similar to many other countries in Europe, Italy being one, Portugal being another, but all of ours coming on interconnectors, DC on interconnectors. Looking across the year, I think it's very interesting that every single month there was a substantial amount of electricity requirement was met by interconnection. In the summer, it peaked. It peaked at about 21% in June. It was about 20% in May, and about 20% also in August. So in the summer months, an awful lot of electricity coming from interconnection. And if you go on to the next one, Kate, I think when you pull together this potential of interconnection with the challenge of intermittency, I think the diagram that EirGrid produce in their winter outlook shows a lot and brings the things I'm trying to describe out much more clearly. So we have a total generation capacity, and this is for last winter, of 14,500 megawatts to meet a max demand of about 6. Obviously, the system operator derates a lot of that because you can't rely on the wind and interconnection we don't control. And then we came to something like, 6,400, 6,500 megawatts. But I think what jumps off this slide for me is the shrinking of the green, the shrinking of the renewables. So it's about 10% of the capacity can be depended on by the system operator. And on the day of highest peak demand, the system operator is having to rely inevitably on an awful lot of fossil fuel. About 76% of the capacity in the derated generation capacity column is fossil fuel of one type or another, be it thermal or combined cycle or the temporary emergency generation. Even something like on the demand side, that yellow part of the bar, hugely derated. So we use the phrase a lot in the reports that we write about the energy source of last resort. And the energy source of last resort today, it is methane, whether it's natural gas or biomethane, that's what it is. And there is nothing on the horizon that can be delivered over the next 25 years that is going to replace that dependency. And if we have a lot of electrification, which hopefully we will, of cars and of heating, and if our electricity requirement and the max demand goes up, at the same time as we're putting a lot more renewables on the system, we're actually going to be having to put a lot more power requirement from fossil fueled generation. And if you go on to the next one, please, Kate. At the core of the report, I think this is in table 20, we do a simple exercise, and I won't go through the full details of this, but we say that if we had an 80 terawatt hour requirement with a 12,000 megawatt maximum demand, and let's say we had 95% was coming from renewables, we're still going to have a big backup generation capacity. And we put that at 12,000 megawatts. So probably that could be designed down a bit, maybe considerably. But at 95% penetration of renewables, we'd have an electricity requirement of 4 terawatt hours coming from this backup plant. And 4 terawatt hours from 12,000 megawatts plant, it's hardly ever running. So you have a capacity factor of 3.8%. So you have a very, very expensive set of assets sitting there doing very little, which you absolutely can't operate without. And we run on down through the figures with bits of logic, which I hope are relatively straightforward to follow if you have a look at the report. And we come up with a natural gas storage requirement of 13.2 terawatt hours, and that'll be LHV, lower heating value of gas, and a send out rate, a very high peak rate of 440 gigawatt hours per day. So if you're optimistic that we can get a lot of renewables, we can definitely make huge strides in reducing greenhouse gas emissions, possibly reducing them by 90%, even at a greatly elevated demand of 80 terawatt hours by 2050. And if you go on to the next one, please, Kate. So the dependence on fossil fuel as the specifically natural gas as the source of last resort brings us to the issue of energy security. So this is, I'm sure most of you will have seen this from the EirGrid website, but if we look compare 2014 with 2023, back in 2014 we had a lot of the electricity came from coal, and the coal was backed up by a yard full of coal down at Money Point, which, as far as I know, had the potential to generate about 2 terawatt hours of electricity at putting it out at about 900 megawatts. We had peat-fired stations, and they had great big stores of peat, so they gave significant energy security. Natural gas, we actually had gas storage down in Kinsale, as well as the Kinsale field operating and producing a lot of the country's gas. And if you roll forward to 2023 and indeed to today in 2025, we've no energy security from that yard full of coal. We have no energy security from peat, and we have no energy security from stores of natural gas. And I think it's extraordinary. I think it's actually a very naive thing in Irish energy policy that we have moved on the basis of a single objective of taking greenhouse gas emissions out of energy, and we have entirely ignored until recently, comparatively recently, the issue of energy security. Energy security is not an issue until it becomes an issue, and maybe it's because I'm old enough to remember the energy shocks of the 1970s, the establishment of NORA. I just think we're one major incident away, and it could be a geopolitical one, from having a major energy shock in the country, for which we are exceptionally ill prepared, and that's not a good situation for Ireland to be in. And we are definitely in the Academy saying this needs to be front and centre of energy policy, along with the other issues or the other legs of the energy trilemma. And if you go on to the next one, Kate, please. And one of the arguments that is made about not developing a big LNG capacity, and it's actually in government policy and in the policy documents, that apparently as a country we don't want to have extra supplies of natural gas because it would cause increased demand. And when I read this, I read it in the policy document and said with some disbelief. So worthwhile just to take a moment. If you look at natural gas in the energy balance, and these are SEAI figures, so again, I think they're lower heating value. I think GNI will typically use the upper heating value. But anyway, 48 terawatt hours of gas in primary energy in 2023, about 28 of that used in generation. Of that 28, going back to the table 20 figures I had earlier, you could maybe think about taking 20 out of that entirely. So it really doesn't matter how much supply capacity Ireland has. If you're decarbonizing generation, that 28 is going to come down to something like 8. In the final energy consumption, then natural gas is about 19 terawatt hours. So about 10 of that, 9.9 going into industry, and the biggest lump of that I think is EnergyEnvironmnet. It's something like 7 terawatt hours, which is going to be one of those hard to abate sectors. So there's definitely going to be some demand for natural gas. But again, I don't think that the availability of an alternative supply from GNI's pipelines from an LNG facility is going to cause industry to use more gas. It's simply not. Likewise, in residential, commercial, public, an awful lot of 5.4 and 3.8 terawatt hours, that can be taken out through heat pumps. So I think it's one of the things that we need as we look out to 2050. We need to accept in the generation space, there's still, because we can't say what the alternative is today, there's still going to be some demand for natural gas there. I think it's inevitable there's going to be significant demand within industry. Residential, commercial, and public will depend on how much we can get people away from gas and oil boilers, but huge progress should be doable there. But we are going to end up with some residual amount of natural gas dependency in 2050, and I think that's all but inevitable. And if we go on to the next one, please, Kate. So at the core of the report, we tried to get a sense of what's the project delivery challenge that Ireland faces. And all of the figures here, they're explained through the text of the report, they're explained in the appendices. So they're what the assumptions are. So on the onshore wind, we're saying we might need 4,270 megawatts extra on top of the 4,730 that we had last year. That's to hit the target of 9,000. At about 60 megawatts of wind farm, that's 71 projects. And if you carry on with that logic down through the figures, what we end up with in a 25-year period is a requirement to build out 350 projects. Now, you'd want to be very optimistic to believe today, based on what we know, what we can see happening, to think that 350 projects are going to be built. And the one I would highlight most, I suppose, is the transmission lines one. EirGrid back in, I think it was 2008, published Grid 2025. And in that estimated there was a need for 1,150 kilometers of overhead transmission lines. And that's at 220 and 400 kV. There isn't a single such project in EirGrid's 10-year plan at the moment, other than the North-South interconnector, which has been around for 25 years, whose completion date, I'm not quite sure what it is at the moment. It could be, I think I saw 2031. This isn't a criticism of EirGrid, but it is a criticism of the policy situation where there is such an evident requirement for more power, 12,000 megawatts perhaps, higher electricity requirement, 80 terawatt hours against 35. They create an inescapable need for transmission. You just cannot do that without more transmission. And transmission means overhead transmission lines. Those are inescapable. It's not politically opportune, perhaps, to talk about what that need is, but 1,150 kilometers would equate to something like 3,000 40-meter towers around the country. And as long as we don't have that reality front and center in energy policy, then I think maybe fooling yourself is too strong a phrase, but we're not being realistic about what the challenge is. And if you just come to the last slide, please, Kate. So the report overall makes 7 points. And the first one is the obvious one. I think I've repeated this a couple of times. The policy needs to decisively address the challenges of both energy security and the intermittency of renewables. We're just not doing either of those adequately at the moment. A reliance on natural gas as the energy source of last resort is inescapable. And I think that's up to 2050. And there's no solution available today which we know can be delivered, that you can plan on and finance and deliver over the next 25 years. It may come, I wouldn't be optimistic, it may, but as we sit here today, there just isn't. At the core also, the policy has to have some sort of target figure. We put 80 terawatt hours and 12,000 megawatts. I think they're probably a bit on the high side, but in my view of the way to plan great big infrastructure, I think you set your targets high. You plan on delivering the projects to meet those targets. And if your demand doesn't quite come up to 80 terawatt hours or 12,000 megawatts by 2050, nothing is lost. You simply defer some of those projects into the next decade. The cheap part of delivering projects is actually the planning and preparing. In Ireland, we seem to just get to the point and say, gosh, we must build a project. And all of a sudden, the delivery of the project and the planning of it, everything is on the critical path. We just don't plan in advance. The fourth point the report makes is this attempt just to bring some focus on the sheer magnitude of the project delivery, the physical delivery of what is required. Then I suppose we point the finger at government and we say, government has set a target to achieve a climate neutral electricity system by 2050. It has accepted the imposition of enormous financial penalties by the EU if it's not achieved. That's the penalties by 2030, without first understanding and demonstrating how it is feasible. And here I think behind this is, I think there's a lack of engineering input into policy. And too much has been asked of engineers in policy, which engineers haven't developed. We are, as a profession, being asked to deliver what I think is actually the impossible. I think in the academy, we're trying to get that message out. We need the engineering voice to be heard much more. In the sixth point, to the affordability piece of the energy trilemma, we say we have a policy which has been prepared without estimating how much the journey to net zero will cost and what impact it will have on the already high-priced consumers pay for electricity in Ireland. Now, we deal with this at some length in the report on Monday, but I think you can see the consequences of this approach in other countries. In the States, you can now see it in Britain, where I think Richard Tice, one of the leading guys in Reform UK, has written to the likes of Octopus Energy and other renewables companies saying, don't bother applying to the AR7, the allocation round 7 options, because we'll rip up the CFD contracts when we come into power. So I think in Ireland, we need to avoid getting towards those sort of extreme views by bringing that whole cost piece front and center into policy and recognizing that it is a constraint, that if people are think that they're going to have to pay exorbitant electricity prices, they will start to switch off and won't take the decisions that are needed on the supply side to make the energy transition happening. Excuse me. And the final point then in the report is we need an energy policy which goes beyond wishful thinking to recognize energy, finance, project delivery realities, even if the consequence of that could mean having to revise the legal objective of climate neutrality to by 2050. So the key point is supposed to be made. We absolutely support the decarbonisation of our energy systems. But what we're saying in the academy is that there has to be reality in this. Reality on finance, reality on project delivery, and reality on the technologies. So with that, that's me come to an end.